whole setup process where you can download the FTC SDK. And once you set everything up, it comes with a lot of sample code that you can use. So in this tab over here, you can see there's a lot of code here that's actually really useful. And it's a great way to learn and get started. So for example, this like hardware push bot, there's like a bunch of code here that you can look at. So now I'm going to show you guys my code. So the first thing I recommend you guys to do is to create a class for the robot that just contains all the different parts of it, like all the different motors and the servos that you're using. So I just called it Mighty Mechanics Bot. And here I'm declaring all the fields of this class. So all the motors, these are the four motors, the four wheels. So I just called them left front motor, right front motor, and so on. These are the two motors for the intake conveyor belt. And these are the four servos that we used this year. And here's the color sensor. Let's see. And yeah, so I created this method called init over here. And basically what this does is just, it initializes everything, all the motors, all the servos, and use something called hardware map, which is a class that comes with the SDK that you download initially when you're setting everything up. And what hardware map lets you do is it just lets you connect your code to the physical components on the robot. So over here, you can see that I declared this left front motor before up here. So now I'm naming it. So I'm assigned it a name of LFM over here. And so what this means is that when you transfer the program to the phones, well, when you're setting everything up, you have to configure the robot. And so you have to manually type it in on the phone, like name each motor. So in order for this program to not give an error, you would have to name one of the motors on the phone, LFM. And you'd have to do this for every single motor and servo and color and sensor that you use. And over here, I just reversed the direction of the right wheels. And the reason I did this is because so that they're all in the same direction. Okay, so over here, I'm dealing with encoders. So do you guys know what an encoder is? Encoder is basically just a device that allows you to track the speed and position of a motor. And so for the motors that we use this year, they were built in with encoders, so we didn't have to put in any attachments. And so here I'm just resetting the encoders. Yeah, so as you can see, there's different like modes you can set the motors to run in. So for example, you can set them to run using encoders. You can set them to run without encoders, and so on. And here's the same thing as before, except instead of initializing the motors, I'm initializing the servos and just giving them different names such as color arm, rotate arm, and so on, and just initializing to them to a specific position. Yeah, so that's it, I guess, for the main class. So are there any questions so far?
Is there a way to make the screen text a little bit bigger? I'm
Uh,
on my laptop, so it's kind of tiny.
let's see.
Ah, yeah.
Is that good?
Yeah, that's good. And do you know if all our motors have encoders or?
I think most of the Neverest motors probably have built-in
Encoders.
encoders. I'm not sure,
Okay.
but you can usually just check it online.
All right.
Yeah, so I guess I'll just go on. So yeah, so this is the code for the driver controlled period. So it's called gamepad drive, and notice how I put it extends op mode. And so op mode is like one of those predefined classes that come with the FTC SDK that you download initially in the setup. And so any class that you create that extends op mode, you need to implement these two methods, an init method over here and also a loop method. So yeah, so the first line, I'm creating an instance of a class that I showed you guys before. It's called Mighty Mechanics Bot. So I'm creating an object and I'm calling it robot. And over here, these are just a bunch of variables to hold different values for the power of different motors. And so for this init method, I'm calling the init method that I wrote before in the Mighty Mechanics Bot program. So you can see this init method that initializes all the motors and the servos, calling it again, and so I don't have to retype everything. And here I'm using something called telemetry, and this is a really useful feature to use. And telemetry allows you to send data to the phones while the robot is running. So it's especially useful like when you're debugging a program. So over here, I didn't really use it for a purpose. I just used it to send a message to notify whoever is holding the phone that the robot is initialized. And so next is the loop method. And this is the method that just runs continuously as long as the robot is running. All right, so yeah, so now I'm going to show you guys the code for the Mechanim drive that we used this year. So the way I programmed it is that the left joystick controls the movement that goes forward, backwards, and side to side, while the right joystick controls the turning. So I'm going to show you guys a diagram real quickly. Yeah, so this is just a diagram that shows that shows the different names that you can use to access different buttons. So for example, if you want to use the joystick, you would access left stick X or right stick X, or left stick Y or right stick Y.
So the X is moving the joysticks horizontally,
Yeah,
and Y is
and
moving
Y
it
is
vertically.
vertical. And
And if
it's also important to know that um, the joystick returns a value of -1 when you push it forward. So when you're programming it, if you want the robot to go forward when you push the joystick forward, you should just put a negative sign in front to negate that. Um, okay, so I guess I'm going to try to explain how those mechanism wheels work. Pull up the diagram. Okay, so you guys probably know this already, but um, so in order for the robot to strafe from left to right, the wheels move in different directions. So for example, in this example, if you want the robot to strafe right, this wheel would go backwards. This wheel would go forward. This wheel would go forward as well, and this wheel would go backwards. And it would be the reverse if you want to strafe left. So in the program, so I'll just give an example of how this program works. Well, these 4 lines of code work. So if I wanted the robot to strafe right, I would move the left joystick to the right, and that would return a value of 1. And since we're only dealing with um, the X direction, on the left stick, we would only focus on this portion, and all of this other stuff would just be 0, so we can ignore that. So a value of +1 would make the left front wheel go forward, the left back wheel and the right front wheel would go backwards. That's why, because of there's a negative sign here. And then the right back wheel would go forward because there's a positive sign here. So that's just kind of how I got the wheels to move in different directions. Um, so are you guys following so far? All right.
so if the um, left front power, right? If the value combined of the x, y, whatever is 1, +1, it will move forward. If it's -1, it'll turn backwards for each wheel, correct?
Yeah.
Okay, gotcha.
Okay. Um, so the next thing that I did was I limited the range, the maximum and minimum values that um, that the wheels could have.
Mhm.
So I used range.clip, which basically just like I just set a range, for example, from -0.75 to 0.75. So no matter what happens, it will stay within that range. And I did this to prevent it from going too fast. Um, so I think I found that to be very useful. So I would definitely recommend doing that next year. If you find the wheels are going too fast or it's difficult to control, you can always limit the speed that they can go. And the next thing that I did was I put in a slow drive mode, um, which was especially useful for this year when we had to like constantly change speeds and then slow down to improve accuracy. So all I did was that if I if I push down the right bumper I just multiply all of these motor power values by 0.4, so that just reduces their value and slowing down the robot. And over here, this is just the controls for like dumping the glyphs and retracting the glyphs. Retracting the the dumping mechanism. And, and here I'm just setting the powers. So here, so all of this over here was just to get a number for the power, and over here is where I'm actually assigning the power value to the motor. Let's see. Another thing is that there's a gamepad 1 and there's also gamepad 2. So I use gamepad 1 to represent the controller for the driver and gamepad 2 to represent the controls for the operator. So over here I'm starting with the operator controls. So if the left bumper is pressed, like intakes, so it rotates the two motors that are responsible for intaking the glyphs, and the right bumper retracts and it like spits out the glyphs. And here again is like the same thing as before. Just dumping glyphs and retracting the mechanism. And here I used the telemetry again. So this was really useful because especially when things go wrong, it's very helpful to visually see like the position that the servo or motor is assigned to. So over here, I'm constantly, while this entire method is running, you can see on the phone on the bottom, it should show like the position value. So over here, I said to get the position of the left dumper motor or left dumper servo and the right dumper servo, and also the position of the color arm, which was basically just the arm that had the color sensor attached to it. And here's just a stop. It's just a method. So I just set all the powers to 0 and like reset everything basically. So yeah, that's it for the driver control period. Are there any questions for that?
So gamepads one and two are in like this section, right?
Can you repeat that?
Basically, the programming for gamepads 1 and 2 are in this section of the code.
Yeah, like this is the code that I use just for the driver control period.
Okay.
I have a question.
Yeah.
What does at override do?
Okay. Yeah.
That like,
It doesn't really do anything to affect the code itself. It's just like an annotation because so over here I extended something a class called op mode, which I mentioned it was already predefined by the SDK, right? And so I mentioned that you need to implement these two methods like init and loop. And so at override it's just like a notation for the compiler to know that I mean to override the initial method from the op mode. It's kind of difficult to explain, but it doesn't actually do anything to the code. It's just like a notation that helps the compiler catch like an error if there's something wrong. Does that make sense?
yeah.
So
Wait, what did you say about override?
yeah, I just mentioned that it doesn't affect the code. It's just like an annotation
Oh, the
that
hashtag?
helps. No, the at override.
Oh, at override. Oh,
Yeah, like in front. It's just an annotation that like helps the compiler detect an error if like you did something wrong.
okay. Gotcha.
All right. So yeah, that's it for the driver control period. So I think now I'm just gonna show you the autonomous program. I think the autonomous is probably where it gets more complicated than everything else. So this is a program I created for the autonomous. Yeah, so there's a lot of stuff going on, as you can see. So for autonomous, you know that you need your robot to move like a set distance because accuracy is very important. So what I did was I created a that lets you in inches, and then the robot would sense. And so to start off, I just created a whole bunch of variables that I would be using. So there's a variable called counts per motor revolution over here, and this is basically, so this goes back to the encoders that I mentioned before. So the way that the software keeps track of the position of the motor is through the amount of counts that the motor has. So for example, completing one rotation would be 537.6 counts in terms of the software side. And this number is specific to the type of motor that you use. So this was just for the specific motors that we used this year. If you used a different motor, this value for the counts per motor revolution would be different. And this is just gear reduction. We didn't use anything like that, so it's just 1. And then the wheel diameter was 4 inches. And then over here, counts per inch. I basically just calculated the amount of counts. I just divided the counts per motor revolution by the diameter of the wheel to get the counts per inch. And these are just drive speed values that I would use for the autonomous and the turn speed. Yeah, so this whole bunch of stuff is like really messy and looks really confusing. That's the Vuforia stuff. I think I actually got a lot of the Vuforia stuff like from the sample code. So yeah, I think all of this I got from the sample code. Okay, so here's the method called run op mode, and this is the method that executes all the programs when we press run on the phone. So the first thing I did was I initialized everything on the robot, all the motors and all the servos. I initialized the position over here of the dumping mechanism. And then I just sent a message to the phone saying that the robot was initialized and ready. So then there's this wait for start. You can put wait for start here. And what this does is that once you press start, wait, actually, no, so yeah, so the stuff above wait for start, all of that runs when you click init on the phone. But once you press start, yeah, it waits until you press start to initialize everything that's below this line. And so once I press start, you can see that it's basically just step by step everything that happened during the autonomous program. So for example, I lowered the color arm down to scan the color of the jewels, and sleep over here is just like I'm just telling the robot to wait, and I think it's in milliseconds. So like wait for 500 milliseconds, and then it goes to the next line. So then I rotate. So then, yeah, I rotate the arm. Actually, no, I made a mistake. This was just initializing it again, moving it closer to just like setting it up again, and then this is the line where I actually lower the arm to scan the color of the jewel. And arm down is a method that I actually wrote, and it's down here somewhere, a whole bunch of code that, so I'll talk about that later. Yeah, but so then this is just like a step by step of everything that happens. I lower the arm, call this jewel method that detects the color, and then knocks down the correct jewel, and then wait a few seconds, and then activate Euphoria, and then here it scans the image of Euphoria. For example, so if the Euphoria image is left, I execute a whole bunch of code that, like driving forward, turning, and dumping, and all that. And I just inputted different values for all the different scenarios. So for left, center, and right, all of these numbers are just changed slightly. Okay, and then here's a method, encoder drive. This is the method that lets me input a distance in inches, and the robot would then travel that exact distance. And so I have several parameters here, like for example, speed, left inches, right inches, and the timeouts. So left inches, so if I wanted the robot to move forward 12 inches, for example, I would just set the left inches and right inches as 12. And if I want and I can just set the speed from 0 to 1, depending on how fast I want the robot to go. And timeout is just, it just keeps track of how long this method has been running for. And for example, if I don't want this method to take too much time, I can set a timeout of 10 seconds so that after 10 seconds, no matter what, the method stops. And over here, I use something called runtime, something called elapsed time. So that's another class that comes with the FTC SDK. And this is basically just a timer that lets, as soon as you call this method, it starts a timer. Okay, so over here, I'm just determining the position. So I have these variables like new left front target, new left back target. And these are just a bunch of variables to hold the target position that I want the robot to travel to. And so I get the current position of the robot and then add the distance that I want to it. And that becomes the target distance or the target position that I want the robot to travel to. And then over here, using the encoders, I can use this method like set target position, and then I can just enter in the position that I want the robot to go to. And then the robot would travel to that specific position. Yeah. And here, this is just another mode that I can set the motor to. So it's a mode called run to position. So this mode just lets you input a position, and then the motor will keep running until that position is reached. Yeah, and here I'm just like giving power to the motors. All right, so I have a while loop, and I guess the way encoders work is kind of weird. So you actually have to create a while loop, and Yeah, so in order for you have to create a while loop to give the robot time to reach that position. So so I said like while this current motor is busy, or this other motor is busy. So as long as any of the motors are busy, keep on executing the stuff inside the loop. And also, there's the parameter of timeout that I mentioned before. And so basically, as long as the time is less than the timeout time specified, just keep on running the program, and like keep on having the robot move to the set position. And here's just telemetry information that I put to send the current position that the robot is in to the driver. So then after the robot completes its motion, I just set the power to the motors to 0, and I just turned off the run to position mode on the motors. Yeah, and that's it for the encoder drive method I made. Yeah, so this part is pretty confusing. So you guys have any questions on this? You guys are all good?
Can you pull up your screen again? Sorry, with the codes. Yeah. So you basically set the target and you keep it running until it reaches the target, right?
Yeah.
And the target is constantly changing or not? Because it recalculates where you are and then see how much left, right?
Yeah.
Right? And it's keep running until it reaches it, right?
Well, actually, no. I don't think. No, the target position doesn't change.
Target is constant.
So, yeah.
And so, for example, the target would typically be a distance. Is that what it is, or?
Yeah, like for example, like the way that the motor measures distance is through counts.
Right.
So I mentioned like there's 537.6 counts
Mhm.
per revolution.
Right.
So for example, if you wanted to move, and then I calculated over here the counts per inch.
Yeah.
So if I input 12 for 12 inches, then it'll calculate how many counts that is.
Okay.
So then that would become
the target.
Yeah, that would be the target position.
Right. So you basically have to rotate X amount until you reach the 12 inches, right?
Yeah.
Okay. So, and it constantly calculates where it is and to see, okay, it rotated like how many times until it reaches the total count, right?
Yeah. Okay.
So a count is basically a rotation, right?
Count?
Yeah.
Well, it's not really a rotation. It's just like a unit of measure that like lets you like it's just a way of measuring position of where the motor is. So like in the software side, so for example, if the counts is 537.6, then the software knows that the motor made like 1 revolution. And I think like for example, if you made 2 revolutions, it would be like 1,000 something, like twice that value. Right. So,
and that value changes depending on the motor.
Yeah. Like it might be the same for 2 different brands, but like you should always check online before doing this.
Where do you find that info?
I think you can usually find it in the description of of where you order it from.
Okay.
Let's see. Okay, so now like moving on, I'm gonna show you guys some other stuff. Okay, so here's the method I used for the joule mechanism. So again, I used. Okay, let me actually. Let me. There's actually one problem I ran into that I'll tell you guys. So over here, when I called this method arm down, and then I called Joule right after it, I had a problem where before the arm was fully went down, the Joule method would already be called, and because the color sensor wasn't next to the Joules, it would just detect the color of basically whatever was in front of it, and so things would just like start just doing the wrong thing, and so that's what I used elapsed time to basically give a set time for that method to run. So for example, in arm down, I put 1.5 there, and so that basically I think so like 1.5 seconds it gives that method to run, and so that was enough time for the arm to fully reach the position I wanted to get into before calling the next method, which was Joule. Okay, so now I'm going to show you my Joule method. Yeah, so here I just different variables to access the colors. So I just focused on the blue color and the red color because that was the color of the Joules that we needed. So basically, I just accessed the color of the Joules, and I compared the value. And if the blue color was greater than the red color value, I assumed that it detected blue. And if the red color value was greater than the blue color value, I assumed that the red Joule was in front. And then I just executed like I just made the arm turn in the correct direction based off of that reading.
Green color for.
Yeah, that was something I didn't use that, but I was like playing around with something and I just didn't delete it yet. But I didn't use it in this code, like in this method. I think that's it for the most part. The rest of them are just pretty simple methods, just like changing the position of a servo or a motor.
Can you go into the Vuforia going left, center, and right a little bit?
Yeah. So what specifically about it?
So when you say the view mark equals, and then you have relic recovery view mark dot left, that's
Yeah.
already given. Is that just a value or?
Yeah.
So that was, we didn't have to write anything, right? That's it came with the like the library or something, right?
Yeah, I'll show you like where I got that from. Oh yeah, so here is the sample code. Yeah, and usually in the sample code they have a lot of like unnecessary stuff as well. So when I put that into the final code, I just deleted all of the stuff that wasn't necessary and added anything else if I wanted to add anything to change it. Yeah, so this is where I got like a lot of the Vuforia code from. And usually they give you the sample code for most of the stuff. Yeah. So is there anything else that is a bit confusing? Because I went through it pretty quickly.
I have a question.
Yeah.
Let's say there's like something like a sensor that didn't have example code in the uh, Java environment that you're running. Would you go to like the manufacturer's website and look for the code, or
Um, yeah, I don't think usually the manufacturers probably wouldn't give you code, but you can probably just find any like YouTube tutorial or like I think there's like some Reddit forum or something for FTC programming if you want to use other sensors.
Yeah, there's a FTC Reddit forum that's pretty extensive, and if you ask questions, they're usually pretty helpful. People can, you know, give you some hint and guidance. In terms of strategy for next year, what would you recommend for whoever's going to be, programming? Like, what would be the base thing? Do you recommend they, kind of start with the drivetrain and then make sure the robot can move, and then go from there? Or what's your strategy in terms of programming?
Yeah, so I wouldn't really say it's a strategy, but I think like getting the robot to move in the driver control period, it's something that you should do first probably instead of autonomous. And getting the robot to move is usually pretty easy to do. You can just like map different buttons on the controller to different functions that you want. Um, I guess
And in terms of the autonomous, what do you find in terms of programming? What worked and what didn't work for you, and what took the longest time?
mm, autonomous. I think most of what I showed you in the autonomous is what I ended up using. I don't think there's anything I did that I ended up not using.
But I think the autonomous, we started saying, let's
Yeah.
not be too ambitious. Let's do,
Oh. Hmm.
this only. And then with that, we got that down. And then we say, okay, let's add more, right?
Yeah, yeah. Usually for the autonomous, there's like really basic tasks such as like driving onto a platform or driving to a specific area. So stuff like that is always like, really easy. So if you don't have enough time, like the easiest thing to do is just to program. Like for example, if you're the first qualifier, you were too busy building the robot and you didn't have time to put in a good autonomous that you had a lot of time to work on. And just usually there's like some really easy tasks that you can just do in 3 lines. Just like drive the robot into a specific area. I don't know.
How much time, you see, before the competition, you think the programmer needs dedicated? Because I know we dedicated some time
Yeah.
for just the programmer, alone, without the rest of the team. How much time you recommend that period to be?
Mm.
A day, half a
Like
day?
like just for autonomous or just
Well, just like, the first qualifier, I think we didn't even have autonomous, right? Or we did, we just
yeah.
didn't use it. Um, and we really just wanted to get the robot, working. And then I guess the second qualifier, we had everything working, right? Or was it till
Yeah.
the final? I can't remember.
I don't
I
remember.
think the second one, if I'm not sure. I think we had autonomous, but we didn't really trust it, I think.
Yeah.
Right. And then I think at the championship, we had a really good autonomous. I think we finally got
Yeah.
it nailed down.
Wait, so are we gonna get like another Rev module? Like,
um, yeah, I mean, whatever recommendation you have, from this year, we'll take it into consideration. So we'll place the order early on.
Okay,
If
because
they
like
run out.
having a second like robot for the programmers is like a really helpful thing to do, especially if it's your first year learning it. It's really helpful to implement it and run it to see if it actually works.
Hmm. So you're saying having a duplicate set.
Yeah, that would definitely
So
help.
with
'Cause-
all the electronics and everything.
yeah,
All right. Yeah,
because the
last
thing,
year was the first time I think we're using this system, so it was very challenging. What were you saying? Sorry.
what?
You were saying something?
Oh, no, I don't think I was saying anything.
Oh, somebody was.
Hmm. Yeah, another thing I didn't mention is that there's like a documentation for anything that if there's a term or something that you don't understand. I think it's on the. You can just like search it up online. Um, over here, here's like it contains a lot of information. For example, if you don't know what hardware map is, it's over here. You can find out everything about it.
Can you share that link?
Yeah, I'll just paste it.
Okay. And if you can share that controller map also.
Yeah.
And also the mechanism wheel drive image, that was pretty good.
What, the diagram or?
Yeah, the diagram. I know you just Googled it, but I think it's good.
Oh,
It's helpful.
okay.
Yeah.
I think this was a YouTube video I think that I looked at when I was trying to do the mechanism wheels. So I'll put this link in there too.
Just curious for Nathan and Mark, what do you guys think of the mechanism wheels? And is that something you would like to use next year?
Well, from what it seems to be like next year, I don't know if we'll be able to use mechanism wheels because people are saying it's going to be a terrain game or something like that.
Yeah, I think, yeah, you're right. We have to see what the challenge is
Yeah.
before we decide to drive.
But if we can't use mechanism wheels again, we should definitely use it because they're fun.
Yeah.
They are fun. They're so fast. I mean, this year, because of it, that we were able to very quickly move and maneuver. I mean, that was beautiful. Okay. The Brian has also put the codes in Google Drive, which Brian, if you have it, you can share it again, and I'll grab all the links and write it into an email and send it to everybody as well.
Now, I've actually found some of the code in the Discord
Oh, okay.
program.
Good.
Oh yeah, I think I put it in there at one point for Jeremy.
Yeah.
Very good. I feel good to have the two of you, especially Nathan and Mark. So this way, because Jeremy unfortunately couldn't make this call, but to have the three of you being on top of it, that'd be really good. The other thing I like to get is have somebody to get into CAD because we really didn't have anybody doing the CAD. I think Alex did a
yeah.
little bit,
Yeah.
but I think that's an area that we should really get into. The manual part 1 was released today. I think it was today or yesterday. It's online in the FTC forum, so you guys can take a look at it and see if there's any changes and new stuff.
Yeah, they said something about adding a new like game element other than the robots. Something about like team markers.
That's interesting. I don't know what that means.
I think it's supposed to be some sort of like rectangular prism with your team numbers on it. They only just put like size specifications and the numbers. That's it.
Okay. The full game will be released, I believe, end of August. So as soon as it comes out, I'll let everybody know. Does anybody else have any question for Brian? You can ask him anything. So when do you leave town, Brian?
Well, I need to get there by August 29th.
That's in Michigan, right?
Yeah.
Cool. August 29th. Yeah. Do you think we can reach out to you if we have any questions? I know you're going to be busy, but would you be willing to be our backup mentor?
Yeah, I'll see, but I don't know how my schedule is going to work out. So
Yeah, I'm sure you're going to be quite busy. But do you mind if they have any kind of email questions, they can reach out to you?
yeah, that's fine.
Cool. I really, really appreciate that. Okay. Well, if you guys don't have any other questions, we're going to let everybody go. Thank you very, very much. And I'll post the recording so that others can hear it as well.
Okay.
Thank you so much. And good night to everybody.
All right. Good night.
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 Thanks.
Thanks.